session, we'll be discussing how Naive Bayes algorithm will be processed. In the previous video, we have discussed how Naive Bayes formulae can be derived from the Bayes theorem, basics of the Bayes theorem, and we have calculated the probabilities of the heads and tails using the coins and all. So from that, we have derived the formulae P of C given x equals P of x given C into P of C divided by P of x. This is the Naive Bayes formula which we have discussed in the last session. Now, using this formula, now we are going to find the probability for the given sample. Now, we will take an example of the training data in which we have 5 data samples in which we have 2 different features, age and income. Now, based on age and income, they are classifying whether that particular person will buy computer or not. So, according to the first sample, if age equals young and income equals high, buys laptop equals no. So, this is how we have 5 different samples in the given training data. And they are asking us to find whether the person with age equals old and income equals high will buy computer or not, or buy laptop or not. This is what we have to classify. This is the classification. Since we are saying it is a binary classification, because in buys laptop, this is the class label for our training set, which consists of only 2 values, no and yes. We have only 2 values, yes and no, in buy laptop. This is called the outcome of this sample, that is class labels. So in class label, we have 2 classes which is said to be a binary classification. So by strongly, we are accepting to apply the Naive Bayes classification algorithm here. We have 3 different steps in order to process this. We have to say whether this person buys computer or not. Let's find out using Naive Bayes algorithm. In step 1, first we have to find the prior probability. So how I can find the prior probabilities of the given data set? In the training set, we have to find how many class labels are there. As I said, we have 2 class labels, yes and no. Since it's a binary classification, we have yes and no. We have to find now the probability of yes and no. That is the prior probability. So how many yes we have? We have 1, 2 and 3. So totally we have 3 yes labels. So 3 out of 5. And obviously we have 2 no, right? 1 and 2, or no labels. So totally we have 2 no labels out of 5. This is how we have to find the prior probability for the given set. And what is the next step? Step 2 involves calculating the likelihood probabilities. Right? How we can find the likelihood probabilities of the given data set? So let me take with 2 tables. Since we have 2 features, I'm going to take the 2 tables. It's based on the number of feature which we have. So we take this. What is the first feature I have? Age. And the second feature is income, right? So let us take age and income. Writing the age and income here. So in age, how many values I have? Young and old. We have only 2 values. If you have more than 2 values, you have to write all the values and find the probability of all the values for the age. Young and old. Right? How many class labels I have? 2, yes and no. So for age young, how many yes are contributing, and for age young, how many no samples are there? That should be calculated and written in the table. Similarly, for income, we have 2 labels, high and low. So let us write high and low. We have 2 class values, yes and no. Now let's find the probability of young and S. How many young and S are there? Let's check. We have 2 young here, right? 1 and 2. These 2 are young values we have. For this two young values, we have to check what is the outcome of this by laptop. Both are no, right? No S values are there. The first sample also contributing to no, and the second sample is also contributing to no. So S equals 0 for the young. So let us 0 divided by 3. Why I am giving it as 3? Because in probability of yes, what is the total outcome of yes? 3. Out of this 3, I have 0 contribution for young. Clear? And for old, let us take age equals old with probability of yes. Now we have already found the probability of yes here. What is the probability of yes here? We have it as 3, right? Probability of yes is 3. So that is common for all yes labels. Now, how many old are contributing to us? We have old as 1, 2 and 3. 3 old. For this, all 3 are contributing to S, right? So, all 3 are contributing to S. Similarly, you have to find for young and no. For no labels, let us write first the total probability. What is the total probability of no here? The probability of no is 2, right? The total probability is 2. So let us take with 2. Out of 2, how many young are contributing to no? That we have to know. So we have 2 young here, 2 young, both the youngs are contributing to no. So the value is 2 here. 2 by 2, right? And in old, how many no are there? In old, how many no are there? This is also S, and this also S, and this also S. No are there, so it is 0. How many the total probabilities? 2, right? Similarly for income, how many income high are contributing to S? What is the total probability of yes here? Yes is 3, right? That is same for all. It is for 3, and low is also for 3, and for no we have the probability 2. This is same for all. Now high and S, we will check with high and S. Income high and S. We have here high, it is contributing to no. This is also high, this is no. And for this high we have yes. So for high we have 1 yes and 2 no. I'm going to take with 1 yes and 2 no. And let's take with low now. So for low we have this low contributing to S, and this low is also contributing to yes, right? So now 2 lows are contributing to yes. So let's check with here. 2 low contributing to yes. And here it is 0. Sorry, it's for S and no, right? So this is how likelihood probability will be calculated for the given training data set. Once we have found all the likelihood probabilities for the given data set, the next step 3, we are going to apply Naive Bayes algorithm and check what is the outcome of the given sample. So for this, we have P of S given X. X is nothing but the given data set. What is the data set? It is given the sample. Age equals old and income equals high, right? Age equals low and age equals old and income equals high. For this, we have to check both the probability of yes and no. Whichever have the higher probability, that will be given as the outcome. If for instance, if I am having probability of yes as higher value, then we can conclude and classify that the given sample will by laptop. So here how I can write it? P of yes, the prior probability of yes, that should be multiplied with the probability of what is it, old and high, right? For old, how many yes will be given? Let us make it clear. Old yes that should be multiplied with probability of the next income is high. Income is high given S. Here we are going to find only for S value, because we are finding the probability of S given the sample. In the sample we have only age equals old and income equals it. That's why I am taking only old and high probability for yes, because I am going to find the probability of yes for only the given sample. I am going to classify only the given sample. So in the sample I have value of age as old and income as high. That's why I am taking old and high alone. If there are some other values like young is given, then you have to replace it with young. It is only purely based on the given sample which you need to classify. So now we have to find the probability of yes given sample using this formula. Now what is P of S? It is in the prior probability. What is the probability here? P of S equals 3 divided by 5. Let me take 3 by 5 into, what is the probability of old and S? This old given S and high given S probability is already there in the likelihood probability table. So we have to check it. Old given S. We have old here, old given S. Right? Its value is here. 3 bar 3. 3 divided by 3. And next, we take with P of high given S. Let us check. P of high is here, S is here. So P of high given S is 1 by 3. So substitute by 1 by 3 here. Right? So this will be 1, 3 by 5 into 1 into 1 by 3. This will give the value of 0.2. Similarly, you have to find for no given the sample. What is X? Age equals old, income equals high. Right? For this, already we have found the probability of yes here. What is the probability of yes here given the sample? It is 0.2. Now we have to find the probability of no for this, so that we can compare and check which is higher, and that will be placed as the class label. So for no, we have again the formula, the total probability of no sample from the prior probability, that should be multiplied, that should be multiplied with, let me not write x here because already it's in a term, so it will be the dot product. Probability of, what is the value here? Old, right? Old given, for what class we are finding? No. Multiplied by probability of, here it is high, the next feature, high given no. Now what is probability of no here? We will find it here in the prior probability. Probability of no is 2 divided by 5. We'll write 2 divided by 5 into, what is here? Probability of old given no. This should be found in the likelihood probability table. Old and no. We'll take this old, and for this no we have 0 by 2. We'll take it as it is 0 by 2 into probability of high given no. High given no, here it is, high given no, 2 divided by 2. So I'll take 2 divided by 2. If I use this 2 by 5 into 0 into 1, here 0 dot product anything will be 0 value, right? So now the probability of S given S, probability of S given X equals, it is 0.2 here, and probability of no given X is 0. So this is the final probability value we have found for the given sample. And now compare this to, this is highest than this. So probably a person with age equals old and income equals high will buy laptop. So it will conclude with class label. So this given sample is classified with the outcome yes. This is the classification procedure which we should follow for Navy based classification algorithm. Thank you.